In this module, we're going to talk about both single and multi-dimensional arrays and how they're used to store both primitive and object types. So let's begin. In this module, we're going to learn how to declare and create arrays, which will allow us to hold primitives and objects. We'll learn how to initialize those arrays, as well as determine the number of elements that an array can hold. We'll also learn how to create multidimensional arrays and how to copy values from one array to another. So what is an array and what is it good for? Well, in Java, an array is an object that allows us to hold multiple primitives or multiple objects. So instead of having to create, for instance, 10 variables of type int to hold 10 integers, like we have in the edit window to the left, we can instead create one array variable that will hold all of those values for us. Those values are called the elements of the array, and each element will be stored at a different index in the array. An index is kind of like the slot of the array. So we have three examples here. We have an array of ages that take integers. We have an array of shirts, which hold references to shirt objects. And we have an array of names, which hold references to string objects of people's names. Now notice that all of the indexes begin at 0 and end at 1 less than the size of the array. So the ages array can hold 10 items, so it begins at index 0 and ends at index 9. The shirts array can hold 5 shirts, so it begins at index 0 and ends at index 4. And the names array can hold up to 6 names, so it begins at index 0 and ends at index 5. So let's see how we create arrays in Java. So let's take a look at the syntax for creating an array. Now I said before that an array is an object, which means that the first thing that we need is an object reference variable to hold a reference to the array object. So the way we create an array object reference variable is we specify the type of values that the array will hold. So that's our type, and that can either be a primitive type or it could be an object type. And then we have our left square bracket and right square bracket to tell the compiler that this is an array. And then we have the array identifier. This is the name that you want to assign to the array. Now that is one form of the syntax for declaring an array reference variable. There is an alternate form, and in that form you first specify the type of object or primitive that the array will hold, then you give the array identifier, and then you give your square brackets. Either way is fine. I prefer the first way because it shows me that I have an array of a certain type. The array square brackets are right next to the type declaration, so I know that I have an array of that type. Whereas in the second form, I have the type that the array will hold, and then I don't see that it's an array until the end of the line. So which one you choose is entirely up to you. So let's take a look at some examples of declaring array reference variables. The first one we have is the status variable. It is going to be a variable that refers to an array of char. Notice that the status variable gets allocated in stack memory, but we have yet to create the actual array object. Same thing with ages. This will be a reference variable to an array of integers. Again, this does not create the array, it just allocates the ages variable in stack memory. And then we have the shirts variable, which is a reference to an array of shirt objects. And lastly, we have the names variable, which is a reference to an array of string objects. Notice that these all get allocated in stack memory just like normal variables do, because that's what they are. It's just that they now refer to an array object. Also notice that no array objects have yet been created. Okay, now it's time for us to actually create the array object. So here's the syntax for doing it. The first thing we're going to give it is the array identifier, which is our array variable that we just created. Then we will use the new operator, because remember we are creating an array object, and then we will specify the type of values that are going to be in the array, and then the length of the array. Now the length specifies the size of the array, or in other words, the number of elements that the array can hold. So remember then that indexes for the array will go from 0 to 1 less than the length that we specify here. So if we want an array that can hold 10 elements of type int, our type would be int, our length would be 10, and our indexes would go from 0 to 9. Now let's take a look at some examples of creating array objects. Now we've already declared the 4 array reference variables from before. Remember, that was status, ages, names, and shirts. And now we're going to create the array objects associated with those array reference variables. So for status, we are going to create a new array. So now that we have created the array reference variable and the array itself, we can now store values in the array. How do we go about doing that? Well, we give the array identifier, which is the name of the array that we gave it, and then in square brackets, we give the index of where we want to store the value. So remember, indexes start at 0, and they go to the length of the array minus 1. So if we created an array of length 10, our indexes would go from 0 to 9. And then we just use the equal sign and give it the value like a regular variable. And then we give it the equal sign and the value we wish to store at that index position in the array. Other than that, it works exactly like any other variable would. So let's go ahead and take a look at a couple of examples of storing values in an array. The first array we're going to store values in is the ages array, which holds integer primitives. As you can see from our animation, we're storing the value 19 in index position 0, the value 42 in index position 1, and so on. Each value for the primitive is stored in the index position. Now, with the array of shirts, which is an array of shirt references, it's a little bit different. We have to create the shirt object as well, and then store the reference to the shirt object in the index position we desire. So as we can see, we are creating 3 shirt objects, and then we are storing the object reference to those shirts in the array. We don't store the shirt object in the array, we store the object reference. Now there is a shortcut notation for creating an array object and initializing the values at the various index positions. So here in our syntax box we see this notation. We declare the array identifier just like we did before. Either you give it the type of element that the array will hold, and then the square brackets, and then the name of the array, or you give it the type of array element that you're going to store in the array, the name of the array, and then the square brackets. Again, either notation is fine. And then you have an equal sign followed by a set of curly brackets. And in the curly brackets, you put a comma-separated list of values that you want stored into the array. Now the size of the array is determined by the number of values in this list. If you have 5 values in the list, you'll get an array of size 5. If you have 2 values in the list, you will get an array of size 2. Now the items in the list must be compatible with the type that you have declared for the array. So if the array is to hold values of the primitive int type, then this needs to be a list of integers. If this array is to hold references to shirt objects, then these need to be shirt object references. So let's take a look at these examples in the edit window above. So we are declaring an array called ages that will hold integers. And then we are giving it 5 integers to initialize the array with. So the array will have size 5, and at index position 0, it will have the value 19, and then at index 1, the value 42, and so on. We are also declaring an array called shirts to hold references to shirt objects. And then we are creating 3 shirt objects. and storing the references to those short objects in the array. So it is completely valid to create the objects inside the curly brackets, like we are doing here. Now, lines 4 and 5 show you an example that is incorrect. You cannot, on one line, declare the ages array variable, and then on another line, try to use the shortcut notation to create the array and initialize it. So here are some more examples of storing values in an array and also retrieving values out of an array. The array variables, along with their indexes, act just like normal variables. You can store a value in it, you can take a value out of it. There's no difference. So for instance, we are storing a 3 character in the 0 index of the status array. And then on line 5, we are retrieving that character out of the 0 index position of the status array and storing it in a S variable of type char. So you see, there's really no difference between using a normal variable and an array variable. They work the same. So now that we've covered one-dimensional arrays, let's get a little bit more advanced and cover two-dimensional arrays. Now, a one-dimensional array is just like a list, but a two-dimensional array is kind of like a spreadsheet. For instance, a calendar that has the days of the week across the top and the weeks down the side. So let's see how we go about implementing a two-dimensional array. Now, just like we had to create a variable to hold the reference to the array object with one-dimensional arrays, we need to do that as well with two-dimensional arrays. But the syntax is just slightly different. Now, because we want a two-dimensional array, we use 2 sets of square brackets. And again, you can either put them next to the type or after the array identifier. This will again create our array reference variable in stack memory. If you want arrays of even more dimensions, like 3 dimensions and 4 dimensions, you just have to have those many sets of square brackets. So now, just like with one-dimensional arrays, we now need to create the array object. But in Java, arrays work slightly different than in most other languages. You see, in Java, we're not actually going to be creating just one multidimensional array object. We're actually going to be creating several one-dimensional array objects. So when we create the array, we will be telling it the number of arrays we want created and then the length of each of those arrays. Again, you can think of these as dimensions in a two-dimensional array, but you have to understand the underlying mechanics of it in Java to be able to fully exploit its strength. So the first number we will be giving it, again, is the number of arrays. Let's say I want to keep track of yearly sales for the past 5 years. And I want those yearly sales broken up into the 4 quarters of each year. So the number of arrays I want is 5. I want 5 arrays because that's how many years I'm keeping track of. Then the length of each of those arrays will be 4 because I have 4 quarters in a year. So let's go ahead and take a look at this example to see how this is done. So here's our example that I briefly explained in the slide before. We want to keep track of yearly sales for the past 5 years broken up by quarter. So we want a two-dimensional array of 5 by 4. But in Java, that's not quite how it's done. What you really end up with are 5 arrays of length 4. Well, actually, as we'll see, we actually have 6 arrays. So let's take a look at this. So in our edit window, we see the line of code that we're going to execute. Yearly sales equals new int, and then 5 for the number of arrays, and then 4 for the length of each array. And then in our animation, you can see what happens. We first get an array that will have a size 5, so indexes from 0 to 4, and this is going to hold references to our other 5 arrays, to the actual arrays that will hold the data. And then each of these 5 arrays will be of size 4. So one array for each of the years that we want to keep track of our data, and each of them will have 4 integers they will hold, one in So now we're going to be storing some values in the various elements of the various arrays. So let's see how we go about doing that. Now, because it's a two-dimensional array, we need two sets of square brackets. First, specifying the array we want to store the value in, and then second, specifying what index position in that array that we want to store the actual value. So let's take a look at some of these examples to help clear this up. So let's say I want to store the value 1000 in the yearly sales 00 position. So what happens is we first would go to yearly sales. That's the variable in stack memory. Now this refers to our array of array references. So we go off to that array and find the 0 index position. Now the 0 index position has a reference to the array that actually stores the ints. So then we would go off to that array and store the value 1000 in the 0 position of that array. So now let's try another example. So in this one, we're going to take 1500 and store it in the yearly sales 01 position. So again, we start off by going to yearly sales, which gives us a reference to the array of array references. And we go to the 0 index position, which tells us what the next array is to go to. And then we go to the index 1 position in that array and store 1500 in it. Same thing with 1800. Go to yearly sales, go to index position 0 of the first array, then go to the second index position of the array referred to from that array. Now let's try the next one. We're going to store 3000 in yearly sales 10. So we go to yearly sales, we go to the index 1 position of the array of array references, and that points us now to a different array than the other three examples. And now we go over to that array, and in index 0 position, we store the value 3000. Same thing with the next one, 1400. We're going to store it in yearly sales 20. So we go to yearly sales, then we go to the array of array references, and we go to index position 2, which then refers us to a different array than the other examples, and we go to index position 0 of that array, and we store 1400 in it. I will leave the last one, yearly sales 3, as an exercise for you to see if you can follow the path that it will take to go and store the value 2000 into the array. As we've learned in this module, arrays are objects in Java, and thus they can have attributes and methods like any other object. Now, one of the attributes that an array has is the length attribute. This tells us the size of the array, or the number of elements in the array. So if we have created an array of size 5, the length attribute will be 5. Now, using this attribute will allow us to avoid ever being out of bounds as far as the array is concerned. Now, if the length attribute holds a 5, for instance, then the valid indexes of the array are 0 to 4. Because remember, indexes start at 0, and so we have to go one less than the length of the array for the final index of 4. So here in our edit window, we see a for loop that we're going to use to loop through the array to initialize it. And every time through the loop, we will store the value in the count variable in the associated index with that count variable. Now, this is the way that we've been looping through arrays since version 1.0. But now we have an additional way to loop through an array. Let's check out the Enhanced For Loop. Click the Enhanced For Loop tab. This is only available in the J2SE 5.0 and later. Now, this Enhanced For Loop does not require the creation of a counter variable, nor does it require the use of an index on the array variable. So you can read this for loop as saying something like, for each integer in my array. So it will loop and grab every integer out of the array one at a time, store that element in the value variable, and then loop through it. So this does the looping automatically, and it can be read as for each element in the array. Now in Java, you cannot resize an array. Once an array has been created, its length is fixed. You can, however, reuse the array reference variable. This is true for any object. You can always reuse an object reference variable. Now, if you do need to resize an array, what you can do is create a new larger array and then copy the values from the original array into the new larger array. And the way to do that is to use the arrayCopy method on the system class, as we can see in our right-hand edit window. In this module, we learned how to declare and create arrays that could hold primitives or objects. We also learned how to initialize the elements of an array and how to determine the number of elements in an array. In addition, we created multidimensional arrays and learned how to copy array values from one array to another.